Everybody, welcome to Studio 64. My name's David, and I've been searching the interzones for some more science, space, and tech news to share with you. And I came across this at Science Alert, with letting us know that physicists finally confirm Einstein's stunning prediction about black holes. This should be interesting. Yes, I'm not a scientist myself, but I love all science and I love sharing news about science. If there are any astrophysicists or astronomers out there, please let us know down in the comments what you think about this. This is absolutely amazing. Now, the detailed mechanics of how matter falls down into a black hole from outside the event horizon have been revealed in a new paper. As predicted by Einstein's theory of gravity, there's a point at which material stops circling the black hole and falls straight down, plunging precipitously beyond the point of no return. Now, in X-ray data of an active black hole, we've finally seen proof that this plunging region exists. Einstein's theory predicted that this final plunge would exist, but this is the first time we've been able to demonstrate it actually happening, says theoretical physicist Andrew Mummery of Oxford University in the UK. Now, think of it like a river turning into a waterfall. Hitherto, we've been looking at the river. This is our first sight of the waterfall. Now, matter making its way towards a black hole doesn't follow a straight line. It circles around like water swirling, spiraling inexorably towards a drain. There is no idle simile. So apt is the comparison that scientists use swirling water vortices to study the environments around black holes. Yes, this is the picture here of the Milky Way with the location of Maxi J 1820 plus 070 marked by a right cross. And now inset we have the Chandra data showing the black holes flickering in 2018. Very interesting. Let's have a little bit of a look. Wow, that's pretty cool. Absolutely amazing. Gotta love this stuff. As I say, no science person. I'm just a student of all sciences, and I love sharing this stuff with people. It's just awesome. Now, studying the black holes themselves is a little tricky because the warped space-time around them is so extreme. But decades ago, Albert Einstein's theoretical work predicted that at a certain proximity to the black hole, matter would no longer be able to follow a stable circular orbit and would fall straight down, like water over the lip of that analogous, depending on how you pronounce it. My mother needs a refund from the Catholic school for all the school fees. Analogous drain. Yes, very interesting. There's no reason to believe that this isn't the case. Matter has to cross the event horizon somehow, and Einstein's theory of gravity has held up to scrutiny across the board. But what astrophysicists have been unsure about is whether or not we'll be able to detect it. Now, the work of Mummery and his colleagues had multiple parts. One of those was the development of numerical simulations and models that depict the plunging region to reveal the sort of light it emits. After that, they need observational evidence that contained the same plunging region emission. Yes, interesting. I have a funny feeling one day we'll be able to develop a probe that will be capable of entering a black hole and sending data back. That would be interesting. People say it's impossible, but then again, a lot of other things in life that were impossible before now are commonplace. So very interesting. I mean, I can remember when the internet first started and I'd be sitting in a room chatting away, and people would look at me and go, he says he's in a room talking to 5 people and they're from all different parts of the world. He's a loony, he's in there by himself. Yeah, and nowadays we talk to people all over the world via social media or by comments in videos like this one, and no one thinks anything about it. So while I'm not completely gullible to think that, everything is possible, I have a feeling that when it comes to black holes, we will find what is in one day. I'm just open-minded. I think it's fascinating. Now, the black hole in question is found in a system about 10,000 light years away, called Maxi J 1820 plus 070. The system contains a black hole, 8.5 times the mass of the Sun, and a binary companion star, from which the black hole strips material as the pair of objects orbit, feeding in bursts that manifest as X-ray flickering. Yes, astronomers have been watching this black hole to better understand its behaviour. So the researchers are able to access very high quality data obtained using the X-ray NuSTAR and NICER instruments in low Earth orbit. In particular, they focused on an outburst that took place in 2018. Thusly, the little video you saw in the intro. Yes, very interesting. Previous studies had noted that there was an extra glow detected in observations of this outburst that could not quite be accounted for. A 2020 study speculated that this glow may emerge from within the innermost stable circular orbit region, that is, the plunging zone. Mummery and his colleagues studied this glow with particular care and found that it matched up with the emission that they derived from their simulations. Yes, the good old plunging zone. That's a little bit of a worry, isn't it? Yes, but yeah, that's where the everything sort of goes, stops swirling and starts dropping, or plunging in this case. Fascinating. This, the researchers say, finally establishes the existence of the plunging region, without question giving us a new probe for the extreme gravitational regime in the region immediately outside a black hole's event horizon. Now, what is really exciting is that there are many black holes in the galaxy, and we now have a powerful new technique for using them to study the strongest known gravitational fields, Mummery says. Now, we believe this represents an exciting new development in the study of black holes, allowing us to investigate this final area around them. Now, only then can we fully understand the gravitational force. This final plunge of plasma happens at the very edge of a black hole and shows matter responding to gravity in the strongest possible form. Now, the research has been published in the monthly notices of the Royal Astronomical Society. Yes, the venerable Royal Astronomical Society. Absolutely amazing. Completely amazes me what some of the stuff that we've come up with in the last few years when it comes to science and the discoveries in outer space. I just think it's absolutely amazing. I've done a few videos on it recently, and it just completely and utterly blows me away. We're just progressing so fast now; it's just awesome, and I'm just hoping I'll be around long enough to maybe one day we'll get a probe that can show us the inside of a black hole, or even a probe that goes to the moon of Enceladus and discovers life in the ocean or something like that underneath the surface of that. That would be fantastic. As I say, I just love sharing these science and news stories with people. I just hope that people enjoy them, because it's to me, it's just absolutely amazing. I get all excited down in my nerdy nether regions, but then again, my personal life is no concern of yours. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I greatly appreciate it. And if you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
I'll be back.